GeoAI and ethics intersect in fascinating and complex ways, raising interesting questions about the responsible use of artificial intelligence in geospatial contexts. The use of AI in decision making and research is growing rapidly, and with that comes the need to scrutinize its ethical implications. In this module, we'll focus specifically on GeoAI's application in processing imagery and massive geospatial datasets, examining the challenges and the opportunities it presents. GeoAI leverages vast amounts of data to detect patterns, analyze trends, and predict outcomes. While powerful, these capabilities also carry risks. Maps and data can be misused, and the algorithms powering GeoAI often reflects biases inherent in their training datasets. This is particularly relevant when we consider imagery data and its role in extracting information. Ethical concerns arise not only in the selection and use of training datasets, but also in understanding who has access to the raw data and processed data and who ultimately benefits from it. One of the key ethical challenges is ensuring that GeoAI is not assumed to be neutral. Like all AI, it carries biases rooted in its design and implementation. These biases can perpetuate inequities if not intentionally addressed. For instance, in building training datasets, the process often depends on the data that's most readily available. A researcher in Santa Barbara might create a data set of building footprints using local data, which might include university structures, luxury homes, and high density apartments. While this data set could be effective for analyzing buildings in Southern California, it would likely fail if applied to areas in the global South or Northern Canada where building styles and needs differ significantly due to geographical and cultural contexts. The lack of representation in training data leads to biased models, which at best fail and at worst reinforce existing inequities. GeoAI work tends to be concentrated in certain regions, leaving large parts of the world underrepresented. This creates a feedback loop where models and solutions developed reflect the priorities of the areas where data is most abundant while neglecting or misrepresenting regions where data is scarce. The extractive nature of remote sensing data compounds this issue. Imagery and geospatial information are often gathered from regions in the global South without reciprocal benefits or local input. These practices can reinforce neocolonial dynamics where the global North controls the data and its applications, further marginalizing communities in the global South. To counteract this, a co-design and co-ownership approach to data projects is essential, ensuring that communities are involved in decisions about how their data is collected, processed, and used. Even at local scales, similar problems can arise. For example, in studies on biking behavior, training datasets often come from city environments where data collection is easier and more frequent. These datasets may include bike counters placed in urban areas to measure ridership, but they fail to capture patterns in suburban or rural areas. Models trained on this data may work well for cities, but fall apart elsewhere, highlighting the need for diverse and representative training datasets. Access to data presents another ethical challenge. Raw remote sensing data often requires specialized tools and expertise to process, which can exclude many communities from engaging with their own geographic information. Meanwhile, processed data reflects the priorities and biases of those who control the algorithms, which may not align with the needs of the communities the data represents. To address these issues, efforts should focus on democratizing access to geospatial analysis, promoting open source tools, and fostering collaboration to prioritize equitable resource sharing. These considerations bring us back to the core themes we discussed throughout this curriculum: representativeness, inclusivity, and intentionality. GeoAI amplifies the importance of these themes because its reliance on massive datasets and predictive modeling has far reaching impact. When building and using GeoAI models, Researchers must recognize the responsibility they bear in shaping narratives about the future. Patterns identified and mapped by AI tells a story. And if the data feeding these models is incomplete or biased, those stories will be too. Ethical GeoAI requires thoughtfulness about training datasets, an acknowledgement of the biases inherent in AI, and a commitment to expanding representation in the data we use. By intentionally addressing these issues head on, we can create GeoAI tools and models that drive meaningful change.